We are going to start with lesson 50, talking about polynomial equations. And first we're going to review what the degree of a term is. If we have a number like 2x cubed, we look at the exponent of the variable to decide the degree of the term. So since this is a 3, we call this a third degree term. Then if we have just an x, because technically it's x to the first power, then it's a first degree term. And we can do the same thing when we talk about a polynomial. So an example of a polynomial is this one. It's like a grouping of terms. And if we want to decide the degree of this polynomial, we'll look again at the exponents. So the first term is a third degree term. The second term, because it has two variables, we need to add their exponents together. So this is a second degree term. And the third term is a first degree term. So we take the highest one, which is the 3. So we call this whole polynomial a third degree polynomial. Now we can take it one step further and talk about polynomial equations. So this was just an example of a polynomial because it's just 3 terms added together. But if we have an equation or a polynomial equation, let me just give an example of that. It could be any polynomial that basically has an equal sign involved. So when we look at this one, again, when we have multiple variables within the same term, we're going to add their exponents together. So this is a third degree term, this is a first degree term, and technically there's no variable here, so it's a 0 degree term. So the highest term is this one again, and it just happens to also be a third degree. So this is a third degree polynomial equation. So these are individual terms that we're deciding the degree on. This was a whole polynomial, and this was a polynomial equation. So again, when you're doing these, we just want to find the term with the highest degree, and that's how we're going to name the whole equation. One reason this is really important is the degree of the equation will tell you a lot about the equation. So as you get into higher level math, it becomes important to look at an equation and be able to say, oh, if it's a first degree, second degree, or third degree, it makes a difference later. So they just want you to learn how to spot it now. And the degree you'll be working with for a while are first degree equations. So here's an example of a first degree equation. Y equals 2x plus 4. It's first degree because if you look at all 3 terms, this term and this term only go to the first power. And since that's the highest power, it's a first degree equation. As you're probably starting to learn, that a first degree equation, if you graphed it, it would be a line. And then we would call it a linear equation. So as soon as you see that nothing is squared or cubed or to another power, it really helps us know, okay, this is likely a line. And when you have an equation, you can put in an infinite number of possibilities for x to solve for y. So for example, if I put the number in, if I said, if x equals 2, what will y equal? Well, if x equals 2, I'll rewrite my equation and just plug a 2 in where the x is. So this becomes 4 plus 4, or y equals 8. So I can erase that question mark and say, well, when x is 2, then y will equal 8 in this equation. And I could do that for so many numbers. I could put a -5 in for x, solve it, and find a different number for y. So I could use an infinite number of things. So we can replace the x with any real number and use this equation to find the value of y, and that the equation pairs with and the value of x. So we can find an infinite number of xy pairs, and we would write this pair as 2, 8, because we always write the x first and then the y. But we could write an infinite number of ordered pairs from this equation. Okay. Looking on in the next part, that's what they wanted you to review for polynomials. And then we're going to talk a little bit more about ordered pairs. So when we're given the equation, y equals 2x plus 4, when we let x equal 2, we found that y was 8. This makes an ordered pair. Also, we could, if we plug in, let's say, if we want x to be, oh, sorry, I got a little off there. If we want x, if x is a -5, what is our y value? Well, to solve this, we just plug in a -5 where our x is. And when we solve it, we'll just solve one thing at a time. So my first step, I multiplied these two together to get a -10 and rewrote my +4. And my final step, I'll add the -10 and the +4 to get a -6. So I would write this ordered pair, now that we found that this question mark is a -6, I would write this ordered pair as -5, -6. So again, now we have two ordered pairs that we found from the equation of the line that we had. And again, it's important to remember that in ordered pairs of x and y, the first number will always be the x and the second number will always be the y. So you never want to switch them around because it definitely changes. And then the last thing they wanted to talk about in this particular lesson is the Cartesian coordinate system. So I'm going to flip my page and get on a fresh page for you. So all that it's referring to, the Cartesian coordinate system, is, I'm going to start with like a number line. If we have, and you'll have to pretend that all my numbers are very equally spaced here. If I'm going to graph x equals 4, I can find it on a regular number line and mark x equals to 4. Or if I'm doing an inequality, if I'm doing like x is greater than or equal to -2, I'll make a new number line. And I like to include a lot of numbers close to the number that we're dealing with. So if we have a -2, if it's greater than or equal to, instead of just filling it in because we had one thing it was equal to, we know it could be equal to -2. So I'm going to fill in this dot, and then I'm going to put a bold line going greater than, and a bold arrow showing that it's all numbers greater than. So this is how you would graph just an x value on a number line, because our x's are always shown horizontally. Well, in the Cartesian coordinate system, we're not just going to graph things on a horizontal number line. We're still going to do that because this is our x-axis. So we're still going to mark our x value on this line, but now we're also going to mark our y value on the vertical line. So when we set things up like this, it creates 4 quadrants. And they name this quadrant the first quadrant, the second, the third, and the fourth. That's just the order they decided to go in. They're going counterclockwise, often because when you graph an angle or something, you always kind of move your angle counterclockwise. So this is the first, second, third, and fourth quadrants. So when we graph ordered pairs of numbers, they list the x first because that's the first one they want us to look at and the first one they want us to graph. And then we look at our y coordinate. So, for example, we're going to do the example of the ordered pair 3, 3. I move my camera a bit so you see it. So, if I'm going to do the graph 3, 3, I'm going to make little tick marks to 5. I'm just going to make it kind of approximate, and I'm just going to sort of ignore my quadrant numbers there for now. If I'm going to graph the pair 3, 3, the first thing I'm going to do is look at my x value, because again, the x is written first, and I'm going to go left or right, or on the horizontal. Because it's a positive 3, I'm going to move to the right 1, 2, 3 steps. I'm not going to mark it right here on this axis. Because it's an ordered pair, I need to move up or down based on my y value. So I'm just going to keep my pencil at spot 3 and look at my y value, which also happens to be 3. So since it's positive, I'm going to move up 1, 2, 3. And that's where I can make my point. So I moved over 3 notches to the right and 3 notches up and found that point. And it's often nice to write right next to your point that ordered pair so you don't forget what you marked there. So let's say in problem B, we're doing -4, 0. -4, 0, because our x value is first, we're going to do our left-right movement first with our -4. Starting here at 0, 0, I'm going to move -1, 2, 3, 4. Again, because it's negative, I went to the left, just like I would do on a number line. And the y value happens to be 0. If it were a positive number, I would have gone up. If it was negative, I would have gone down. But because it's 0, I'm going to stay right there. And it's just like graphing the x equals -4 on a horizontal axis. So again, it's nice to write your point somewhere very close to where you made your point. We're just going to do 2 more. The next one we have is 0 and -3. So now, since 0 is first here, that's my x value. That's showing which way, left or right, I'm going to move. And because it's 0, I'm not going to go left or right either direction. I'm going to stay right here at 0. And then my second number, the -3, is telling me the up or down movement. And because it's negative, I'm going to go down 1, 2, 3. So again, because my x was 0, I'm going to stay right on this line. And this is 0, -3. And the last one we're going to graph is 4, -2. So here my x value is 4. I'm going to move to the right 1, 2, 3, 4 notches. And then I'm going to move down 2 because y is -1, 2. So it'll be approximately right here. Again, when I'm graphing without graph paper, it's not perfect. But if we make our notches as close as we can to being the same distance from each other, and it's not bad when you're working this out, making it bigger is better. You don't want to start a graph really tiny and make all these tiny little marks. It's going to be really hard to keep track of, and it's going to make it hard to have space to fill in your point. So feel free to use a good section of your page when you're doing this. So that's pretty much it for lesson 50. Please let me know if this was helpful or if taping these tutorials would be better if I did it on a whiteboard. I've tried a couple different things, but get back to me and let me know how this is turning out for you. Happy mathing!